children. Today let's continue with exercise 8.2, the application of midpoint theorem. What is midpoint theorem? In a triangle, a line segment joining, midpoints of any two sides is parallel to the third side and equal to half of it. What is the application of its converse? In a triangle, if a line through the midpoint of one side parallel to the second side bisects the third side. So by the application of theorem and converse, let's proceed with exercise questions. Question number 5. In a parallelogram ABCD, E and F are the midpoints of AB and CD respectively. AB and CD are the opposite sides. Underline the word E and F are the midpoints of the sides. Show that line segment AF and EC trisect the diagonal BD. So given ABCD is a parallelogram, it is given that ABCD is a parallelogram and E and F are the midpoints of AB and CD, and then what we have to prove is show that line segment AF and EC trisect diagonal BD. AF is joined, CE is also joined. The points are P and Q. So what is the given condition? ABCD is a parallelogram. E and F are midpoints of AB and CD. What is to prove is DP is equal to PQ is equal to BQ. That means the diagonal BD is trisected. That means it is made into three equal parts. What is to prove is DP is equal to PQ is equal to BQ. And now in a parallelogram, opposite sides are equal and they have given that E and F are the midpoints of AB and CD. So we will be starting the proof with that concept. Proof: AB is equal to CD, opposite sides of a parallelogram. The word midpoint is underlined, which shows that we can take half on both sides. Half AB is equal to half CD, and now half AB I will take it as AE and half CD I will take it as CF. Put it as equation number 1. Then AB parallel to CD, opposite sides of a parallelogram. Therefore, a part of it, no need to write half AB, a part of it AE is also parallel to CF, equation number 2. From 1 and 2, AECF is a parallelogram. Reason is since one pair of opposite sides are parallel and equal. Why did we prove this? We can prove DP is equal to PQ from the triangle in which the side is concerned, and we have to prove PQ is equal to BQ from another triangle, and by the application of converse of midpoint theorem. And so in the converse of midpoint theorem, there should be a line parallel to the base. For that concept, we proved AECF is a parallelogram. In triangle, DCQ in triangle DCQ F is the midpoint of DC. F is the midpoint of DC. Then FP parallel to CQ. Therefore, P is the midpoint of DQ by converse of midpoint theorem. That is dP is equal to PQ. Now we have to prove PQ is equal to BQ. That will be in triangle ABP. Take the triangle A. In triangle ABP, E is the midpoint of AB. E is the midpoint of AB. Again, EQ is parallel to AP. Therefore, Q is the midpoint of PB. Q is the midpoint of PB. Therefore, PQ is equal to QB. Now see, DP is equal to PQ, PQ is equal to QB. Therefore, DP is equal to PQ is equal to QB. Hence the proof. That is, the diagonal BD is trisected at P and Q. Question number 6. Show that the line segments joining the midpoints of opposite sides of a quadrilateral bisect each other. Show that the line segments joining the midpoints of opposite sides of a quadrilateral. So given ABCD is any quadrilateral, then P, Q, R, S are the midpoints of the four sides. What is to prove is the line segment joining the midpoints of the opposite side. That is, PR, Q and S are joined to get QS. The line segment joining the midpoints of the opposite side bisect each other means what is to prove is PO is equal to OR, SO is equal to OQ. This can be proved only by proving that PQRS is a parallelogram. So, given ABCD is a quadrilateral, PQRS are midpoints of AB, BC, CD and DA, and what is to prove is PO is equal to OR and SO is equal to OQ. So, what we have to do is prove that PQRS is a parallelogram, and in a parallelogram the diagonals will always bisect each other. For that, join one of the diagonal AC or BD. Join AC as construction. In triangle, it's a proof as we have done earlier. In triangle ABC, P and Q are midpoints of AB and BC. Therefore, PQ parallel to AC and PQ is equal to half AC by midpoint theorem. Similarly, in triangle ADC, S and R are midpoints of AD and CD. Therefore, SR parallel to AC, SR is equal to half AC. This is equation number 1. Equation number 2. From 1 and 2, PQ parallel to SR, PQ is equal to SR. Therefore, PQRS is a parallelogram since one pair of opposite sides are parallel and equal. Therefore, PO is equal to OR and SO is equal to OQ. The reason, diagonals of a parallelogram bisect each other. That is our proof of question number 6. Last question in the exercise, question number 7. Triangle ABC is right angled at C. A line through the midpoint M of hypotenuse AB is parallel to BC and it is intersecting AC at D. Show that D is the midpoint of AC. The second part, MD is perpendicular to AC. Third part, CM is equal to MA is equal to half AB. Triangle ABC is right angled at C. Right angled at C. A line through the midpoint M of AB parallel to the side BC. That means the condition of converse is satisfied. It bisects the side AC at the point D. So the first part of the proof is very clear. In triangle ACB, M is the midpoint of AB, MD is parallel to BC, therefore D is the midpoint of AC, that is by the converse of midpoint theorem. MD perpendicular to AC. We have to prove that this angle is 90 degree. CM is equal to MA is equal to half of AB. So, let's start with the proof directly. Proof. In triangle ACB, M is the midpoint of AB. Then MD is parallel to BC. Therefore, D is the midpoint of AC. The reason is converse of midpoint theorem. The second part is to prove is MD is perpendicular to AC. You can see here angle C is equal to 90 degree. It is given in the question. Therefore, angle 1 is also 90 degree since BC parallel to MD corresponding angles. So the second part of the proof is done. If angle 1 is 90 degree, therefore MD is perpendicular to AC. Now the third part is CM is equal to MA is equal to half of AB. CM and MA both are in the sides of these two triangles. We have to prove that those two triangles are congruent. So for that, if angle 1 is 90 degree, we need to get angle 2 also. That will also be 90 degree by linear pair axiom. So we can write there as, since angle 1 is equal to 90 degree, angle 2 is also 90 degree by linear pair axiom. Now prove the two triangles ADM and CDM are congruent. In triangles ADM and CDM, the first condition is AD is equal to CD because we proved D is the midpoint of AC. AD is equal to CD, proved. The second condition is angle 1 is equal to angle 2 is equal to 90 degree, that is also proved. And DM is equal to DM common Therefore, triangle ADM congruent to triangle CDM by side angle side by SAS, and now therefore AM is equal to CM CPCT. CM CPCT. It is given in the question that M is the midpoint of AB. So we can write AM is equal to half AB, since M is the midpoint of AB. Therefore, AM is equal to CM is equal to half AB. That is the third part of the proof. This question, mark it as a very important 3-mark question. It can be asked as 3-mark question for any exam. Let's do a few worked out examples which are very important for the exam. Page 143, example 4. Two parallel lines L and M are intersected by a transversal P. Two parallel lines L and M are intersected by a transversal P. Prove that the quadrilateral formed by the bisectors of the interior angles. The interior angles, the bisectors, they form a rectangle. A, B, C, D. So, how do we prove that ABCD is a rectangle? First step, you need to prove that ABCD is a parallelogram. A parallelogram with one angle as 90 degree will turn it as a rectangle. So, let's take the first part as to prove ABCD is a parallelogram. So, the proof will be, take a pair of, let's name it as P, Q, R, S. Since L parallel to M, take a pair of alternate interior angles as PAC. Angle PAC is equal to angle ACS, one pair of alternate interior angles. It's given that AB and CD are the bisectors. So immediately you can take half angle PAC is equal to half angle ACS. Half angle PAC we can opt for 1, and half angle ACS will opt for angle 2. That is, angle 1 is equal to angle 2 since AB, CD are bisectors. But these are a pair of alternate interior angles for AB and CD. Therefore, AB is parallel to CD by converse of alternate interior angles. Similarly, we can prove the pair AB parallel to CD. We can also prove CD parallel to AD. Therefore, ABCD is a parallelogram since both pairs of opposite sides are parallel. Now we have to prove that any one angle is 90 degree. Let's take a linear pair of angles. That means angle RCA plus angle ACS is equal to 180 degree. The reason of linear pair, half angle RCA plus half angle ACS is equal to 90 degree. 2 plus 3 is equal to 90 degree. Therefore, angle C is equal to 90 degree. How do you give the conclusion? Since ABCD is a parallelogram with one angle as 90 degree, it is a rectangle Mark it as an important 3 or 4 mark question. Example 5. Show that the bisectors of the angles of a parallelogram form a rectangle. So, if you look into the figure, ABCD is a parallelogram. The bisectors of angle A, angle B, angle C and angle D form a rectangle. That means we have to prove that PQRS is a rectangle. To prove PQRS is a rectangle. And what is given is ABCD is a parallelogram. So we have to apply the condition of the angles of a parallelogram. So the proof starts as take one pair of adjacent angles so that we can apply the property of co-interior angles. Angle A plus angle D is equal to 180 degree since AB parallel to DC, co-interior angles. Half angle A plus half angle D is equal to 90 degree. Let me take half angle A as 1 and here 2. That is angle 1 plus angle 2 is equal to 90 degree. Therefore, angle 3 is equal to 90 degree by angles and property of triangle. Property of a triangle. Therefore, angle S is equal to 90 degree by vertically opposite angles. Similarly, you can prove angle P, angle Q, angle R. Angle P is equal to angle Q is equal to angle R is equal to 90 degree by this co-interior angles and then angles and property and vertically opposite angle by taking pair of co-interior angles. And now this is not enough to prove that it is a rectangle. First we have to write that PQRS is a parallelogram, then with any one angle 90 degree. How can we say that if all angles are equal, it is a parallelogram? Then since both pairs of opposite angles are equal, how do you present? Since both pairs of opposite angles of quadrilateral PQRS are equal, PQRS is a parallelogram. Also, PQRS is a parallelogram with all angles 90 degree. Therefore, it is a rectangle. This is also an important 3-mark question. Worked out example 6. ABCD is a parallelogram in which P and Q are midpoints of opposite sides AB and CD. If AQ intersects DP at S and BQ intersects CP at R, prove that APCQ is a parallelogram. Then next part, DPBQ is a parallelogram. Third part, PSQR is a parallelogram. Part 1 and 2 are similar. We'll take only one pair. So the proof starts as, since ABCD is a parallelogram, pairs of opposite sides are equal. AB equal to CD and AB is parallel to CD also. That is, half AB is equal to half CD. What can you take half AB as? AP is equal to half CD can be taken as CQ, and since AB is parallel to CD, AP is parallel to CQ also. Therefore, APCQ is a parallelogram since one pair of opposite sides are parallel and equal. Similarly, that half AB is equal to half CD. If you choose for BP and DQ, PB DQD is also a parallelogram. Similarly, DPBQ is also a parallelogram. Once APCQ is a parallelogram, PR parallel to SQ, and since DPBQ is a parallelogram, RQ parallel to PS. So we can mark it as 1 and 2. 1 and 2. From 1 and 2, the first pair is SQ parallel to PR, and the second pair is PS parallel to RQ. You can write here opposite sides of a parallelogram. Therefore, SPRQ is a parallelogram. That is also a parallelogram because both pairs of opposite sides are parallel. Any one of these worked out examples can be asked for a 3-mark question.